Good evening, everyone, and welcome to part 2 of the B+LNZ Genetics Virtual Sheep Breeders Forum. Thank you all for taking time out of your evenings to join us again. We have another great night planned for you all, full of insights and updates, which I hope you'll all find interesting, and of course, followed on by an opportunity for you all to have your say. Apologies for those of you who have heard this a few times already now, but for any newbies joining us tonight, I'll just go through a few housekeeping notes. Please, if you haven't already, ensure your video is off and mute yourselves. You can do this on the bottom left on your screens by clicking mute and stop video icons shown on the arrows on screen now. It will allow us to maintain a better connection throughout the webinar. Along the bottom ribbon of your screens, you will also see the chat icon. Please utilise the chat function for all questions throughout the presentations, and I will circle back to these at the conclusion of each talk for the speaker to answer. For best viewing during the webinar, you can adjust your view in order to see the speaker and their presentation at the same time. The ribbon along the top screen in the middle, you can select view options, then select side-by-side mode in the drop-down list. If any of you need to leave us partway through the webinar, there will be an email sent out on Friday containing a link to the video of this evening's event. There will be a couple of polls throughout the webinar asking you to select which out of a list of options best represents you or your enterprise. For those who joined us last week or last night, you'll be well practiced with these, but to give the rest of you a bit of a demo and to see who we've got signed in tonight, we'll start off the first now. Which of these best describes your involvement in the industry? Breeder, bureau, commercial farmer, science research partner with B+LNZ Genetics, rural consultant, or other? Give you a few more seconds. Okie dokie, so mainly breeders again tonight, which is great to see, and a few more commercial farmers and research partners, which is good. Also some consultants. Welcome everyone. So on to poll number 2, which should come up shortly. How many of you are viewing from your home tonight? 1, 2, 3, 4 or more?
Just to the co-hosts that are on the line, just be careful with the buttons down the bottom that you don't end the polling.
A few more seconds. Okay, most of you on your own, a few more with a couple extras. So again, welcome everyone. Right, before we get to the good stuff, I'll give you a brief recap on what we heard last night for those who weren't able to join us, as well as a rundown on the lineup for this evening. So if you missed last night's session, we heard from Brian Wickham from NZAEL, who gave us an overview of the journey of genetic improvement in the dairy industry. He was followed on by low input progeny test flock manager Robert Peacock. Then we heard from Andrew Morrison and Suzanne Rowe, who gave us some insight around methane, and also finally from David Campbell, who gave us an update on Improve. For any of you who missed last night, there will be an email link sent out tomorrow or early next week with the recording of tonight and last night's webinar. First up tonight, we'll hear from Rob Banks around the use of genomics in expensive or hard to measure phenotypes in Australia. Dan Breyer will offer a New Zealand perspective to this. Then we'll move on to our analysis updates where Sharon McIntyre will share with us a few SIL updates. Cheryl Ann Newman will share some of her research around the DPX index, and Tricia Johnson will give us an update on some newly funded FE research, as well as a rundown on meat quality and feed efficiency. To conclude this evening, we're planning an interactive feedback session where you will all be asked to provide feedback on what you would like to see B+LNZ Genetics focus on in the future. This may include emerging traits or parameters for specific traits, updates to the analysis, queries around indexes, or suggestions for research. This is your opportunity to have a say on what you think our focus should be on in the future. Now, as I did last night to kick things into gear, I'd like to throw to Dan Breyer, our Beef and Lamb New Zealand Farming Excellence and Beef and Lamb Genetics General Manager, to set the scene for this evening's webinar and welcome our first speaker this morning. Thanks, Dan.
Thanks very much, Sarah. Great to have you back. Thank you, everyone who's come along, and thank you for coming last night as well. We had an interesting, informative session and interactive, and we're really looking forward to that tonight. Great to see so many breeders on the line, because that interactive session later on this evening is really important. We want to understand what is important to you, so that we can make sure that we keep Beef and Lamb Genetics heading in the right direction. When I put my Beef and Lamb NZ hat on, I look at genetics and think about, you know, what we do at Beef and Lamb New Zealand. We're about profitable farmers, valued by all New Zealanders, and vibrant rural communities, and genetics is really important to that. So I'm looking forward to your feedback to help us keep heading in the right direction. Just before we get into it, I just want to introduce some of our new team. There's been a few changes around at Beef and Lamb Genetics, so just wanted to take the opportunity to introduce those, and also thank the people who have done so much good work for us over the years, including people like Annie O'Connell, Graham Alder, and Eleanor Lincott. A few new people here on the screen, Anna Boyd and Sarah Powdrell. Many of you will know Anna, and you will have just met Sarah if you hadn't before. So Sarah's our sheep specialist, and our sheep breeders will be seeing lots more of her. We also have, just running down the left-hand side there, Jackie, who many of you will know, Susie Keeling from our science team, David Campbell, who many of you will know as well. Some of the brains behind the operation, Cheryl Ann Newman, Sharon McIntyre and Michael Lee. We'll be hearing from some of those guys tonight. Pam Schofield in the office, and Becky Campbell, who's done such a wonderful job of helping convert what was going to be a really good time up in Napier to a wonderful online experience for us all. So thank you for that, Becky. With that, we'll get into some of the interesting stuff. So I've got the pleasure of introducing Rob Banks. Rob's been involved with genetic R&D in Australia sheep and cattle industry for over 25 years, and in bees as well, I understand. He's going to talk to us about the use of genotypes with expensive phenotypes, and then at the end I'll just circle back about what that might mean for us here in New Zealand. So come in, Rob.
Thank you very much, Dan. Can someone just confirm that you can see my slides, and unfortunately for you, you can probably see me as well. But
Rob, we can see and hear you loud and clear.
And
when you're ready, if you start moving your mouse around on screen, I'll take you back a slide. If you click on the screen, that should advance it onto your opening slide.
Right, there we go. So that's great. Thanks, Dan. Thank you, everybody, for logging in to listen to me and the other good speakers. Or sorry, the other speakers who are good and won't make Australian jokes this early. I was asked to say a little bit about our thinking about reference populations in Australia. And so what I'm working through is not so much detail about what is actually going on in our genomic reference populations in sheep or cattle, as some of the ideas that I've been exploring the last few years about the challenges at an industry or breed level about setting up and maintaining these reference populations. I hope what I have to say makes sense. I'll be moving through it reasonably quickly because I think there's some fairly fundamental points that I want to touch on. Most of the general material, I'm guessing that you'll probably have a good sense of, so I'm not going to be going into lots of technical detail, but I hope you find it interesting, and I'd certainly welcome feedback and I think questions at the end. So just to start off with, in all animal breeding, ultimately the core question is to find which animal's got the best genes, and this talk is partly about how we can find that out. That's two pictures of Romney rams, which, as I'm sure you will have worked out, I got from the web, and I hope I'm not doing anybody any injustice, but we're trying to find out which animals have got the best genes. And we have tools to help us answer those questions, or that question. This kind of standard tool, I guess, that we think of using these days and for several decades now is breeding values. which use pedigree and performance information. Breeding values are a really good tool. They're reliable, they're widely used, but as you would all know, they depend on data. If you don't have data on whatever things you're interested in, you don't have breeding values. If we move on to more recently, we're talking about incorporating genomic information in breeding values, and that's in addition to the pedigree and performance. It's also, genomic breeding values are reliable and they're widely used in lots of species. And just as with breeding values themselves, data is essential, and as you'll see, it's more essential than in the sense it used to be. So I just want to introduce or reinforce the basic idea of genomic prediction, which I'm sure you're familiar with. The first step is to measure lots of animals that you've got phenotypes on, that you've measured performance traits on, and get their DNA or their genotypes. And that's the this group of animals up here, which you'll see my graphic skills are pretty amazing. I copied the same picture twice to make you think there were more animals there. But the idea is that you have a reference population which has got a significant number of animals in, and you measure them for some traits and you genotype them. And once you've done that, and they constitute what's called a reference population, once you've done that, you can then basically just test the DNA on some young animals or indeed some other animals in the same population. And from that DNA, you can predict their genomic breeding value. So the concept's very simple, and I'm sure it's very familiar. You have some animals that you've got phenotypes and genotypes on, and some other animals that potentially you can just test their DNA and get a useful breeding value. Why we're interested in that sort of possibility is really twofold. The first thing I just do want to mention is that having good genomic breeding values buys time, because as this slide's intended to show, the difference between how the accuracy of breeding values, this is the accuracy up this scale, and this is time through an animal's life. If we don't have genomics when we start off, we've essentially got nothing. We can add parent information, and we can add parent EBVs. We can add an animal's own performance records and progeny. And so we can build the accuracy through the life of an animal. And that's the standard breeding values method. With genomics, we can actually go quite a long way up this accuracy curve, essentially from the very minute the animal pops out, or indeed before it's popped out if we want to. In this case, we're talking about a trait that's got a heritability of 25%, and we've got a reference population that generates an accuracy of a genomic test of about 50%. And so, in fact, if we take a tissue sample from a lamb when it's born in this population, we can put an EBV or a breeding value on it with an accuracy of 50%. As further information accrues on that animal or its relatives, that accuracy will rise. But the key thing is, essentially, in this example, we've bought at least half a year's time in when we can get a good assessment of the genetic merit of the animal. So it's buying time for us. That's the first thing that's a really attractive feature of genomic selection. And in a sense, from here on, I'm going to be talking more about what I think is the other big attraction, is that we can learn something about the animal's genetics for hard to measure traits we haven't measured on that animal itself. In the previous example, we were talking about a situation where the reference population was big enough to generate an accuracy of the genomic breeding values of about 50%. And that brings us to the point that that's absolutely fundamental, and I'll keep coming back to it, is that you've got to have performance records in order to make those genomic predictions work, or those genomic breeding values work. This is a very famous slide from a paper of Ben Hayes and Mike Goddard, which just shows us how the accuracy of genomic breeding values that we can obtain increases with the number of individuals in our reference population. I'll come back to the reference population in a minute, but it's basically those individuals that we got the phenotypes and genotypes for. And all this slide is showing is that as the size of our reference population increases, the accuracy of our breeding values rises, and you'll see that these lines correspond to traits of different heritability. So this one here is heritability of 10%, 30%, 50%, 80%. So it's easier to get high accuracy if the trait is more heritable. Another way of saying that is you've got to get more records in your reference population in order to get the same level of accuracy. So for instance, for a trait that's only 10% heritable, to get 40% accuracy, you've got to have about 8,000 individuals, whereas you would only need probably about 800 or 1,000 for a trait that was 80% heritable. So that's kind of the absolute bedrock fact number one, is that genomics utterly, completely, totally depends on performance data. The old phenotypes is the basis of all real estate, I think is the way it goes. The other thing to stress is that the quality of the data that's being collected is really, really important as well. And this is slightly a side issue, but if you've got lots of data, but it's actually relatively poorly recorded, so it doesn't have things like contemporary groups, you might not have accurate age, etc., etc. What you're actually talking about is the heritability of what your records are is lower, and so the effectiveness of the records you're using in your reference population will be lower. Conversely, if you've got really good recording of the non-genetic factors, things like age, contemporary group, etc., birth type, etc., you're going to get more out of the same number of records than you will from poor data. And you'll see why I make this point here. I'll be coming back to it, because it's essentially talking about the effectiveness of the records that you're using in your reference population. And all other things being equal, you want that effectiveness to be as high as possible in order to get the accuracy up as high as possible and basically as quickly as possible of your genomic breeding values. This football-shaped thing is just, to me, it's a kind of sweet spot. You're getting pretty good accuracy. You can make selection decisions quite early in an animal's life. And it's also, for those who are slightly mathematically inclined, this part here is about where all these curves start to flatten off. And in fact, the marginal effectiveness of further records starts declining. And we'll come back to that also in a few minutes. But so I just want to stress, genomic selection is really great because you can make informed decisions pretty early in an animal's life, but it utterly depends on the amount and quality of the performance data you've got. So I'll just reinforce that point there. It cannot be overstated how important those facts are. The complete dependence on performance data, the amount and quality, and it effectively is the construction of the reference population has got to be central. So what I just said about the effectiveness of recording and how the extra accuracy you get with more records is a diminishing returns, it leads on to what I'm really going to concentrate on. Because for me, the key thing about genomic selection is actually that ideally you want the accuracy to be as high as possible for the traits that are really, really important. And that requires us to think about that much more than people, I think, have tended to in the past. But it also leads to the question that if resources, which basically means money, are limited, how should you invest in recording in order to get the highest accuracy? Because accuracy is the base currency we're talking about with genomic breeding values, and you want it as high as possible, as early in animal's life as possible. So I've been thinking about this in terms of how breeds should strategize basically in the genomics era. I've talked about this to beef breeders in various countries and sheep breeders. The reason I talk about breeds is because usually they're made up of a number of a large number of individuals. There might be some considerable number of breeders and potentially a large number of commercial farmers and possibly even other value chain partners. And that raises some challenges which in a sense you don't have when you're applying genomic selection, say in a poultry company or a pig breeding company, where up to a point it's kind of one decision-making process for the entire population. Breeds of livestock, sheep and beef cattle particularly, you've got lots of different players, and the question becomes, well, how do you get this optimal reference population, optimal genomic selection when you've got lots of different players? So we've already said that we depend on lots of good performance recording. It also really matters what traits are important to you. So to make a very simple example, if you had a reference population that had lots and lots and lots and lots of records for example, weaning weight, but in fact the most important trait in your breeding goal was fertility, then your reference population is not quite useless, but not far from it, because if you don't have the data on fertility, then your reference population is not helping you with the traits that are important. Now, I'm not saying that fertility is more or less important than weaning weights. I'm just trying to make an example. If you don't have records on the important traits, genomics is not helping you at all. And that leads on to the question that can be thought of at a breed level is, how many records are you getting for the different traits, and how many animals with records are getting genotypes as well? They're basically the metrics that are going to tell you how useful your reference population is, and hence how much accuracy you're going to get. So just to give examples of the sort of things that I think people need to start thinking about, this is by no means meant to be exhaustive. I know Trish and others will be talking about some really interesting examples in the next talk. This is just a kind of thought bubble, basically, of the sorts of things that people might need to think about in terms of recording, because they'll be easier with genomics. And you can see I've broken a value chain into the commercial farmer, the ewe and lamb producer. I've assumed that you might have a different finishing phase, so the lambs get finished kind of in a separate enterprise. You've got processing and retailing. And there's a whole bunch of traits that I've listed in the middle column here, which we almost certainly have some impact on profitability somewhere in the value chain. And that's an important point. It's not just for the farmer. So all these things are likely to have some impact on profitability somewhere in the value chain. Some of them are moderately easy to record on farm, but some of them will be much easier with genomics, subject to having records. And so the sorts of things I'm thinking might be worth thinking about in this context is being able to get really good breeding values very early in life for fertility. Feed efficiency in this phase, carcass yield, meat flavour, nutrient content. These in general are not easily recorded on farm. And so if you were just relying on the sort of data that ram breeders could record, it wouldn't actually help your reference population that much in terms of dealing with these traits, being able to address these traits. So the question of what traits are important, and then which traits do we get lots of anyway, and which might we have to invest in separately, I think become absolutely central to a breed or to an industry to think about. And that kind of leads to a recipe for success. I won't spend on much time on this now. It probably should be a much later slide. But it's sort of setting out that you can define the strategy for a breed in terms of these 6 steps that need to be managed effectively. And I've started with what traits are important. We just talked about that. We've got to define what traits are important, because ultimately they're going to define what we should be investing in to make sure we've got enough records in our reference population. Then we've got questions about actually designing the reference population. And I think in general, it's going to be a mixture of specific flocks where you're doing some R&D, like for instance, the low I can't remember the exact word for it, but the flock that Robert Peacock is managing that was talked about last night. There's certain things being recorded there which are, in a sense, it's a special R&D flock. There might be other flocks where you're getting, for instance, individual feed intake. And then you've also got on-farm recording in studs and potentially commercial operations. So you've got two arms, if you like, of your reference population, and whoever's thinking about the breed needs to think about how to coordinate those activities. Having really good protocols in place for the data quality is important, because even if you think you're getting data for free, someone has actually spent some time or money generating the data, and it's worth making sure that the data is as useful as possible in terms of generating good genomic breeding values. It's basically making the heritability of the data as high as possible. So having really good protocols for data quality checking is going to be increasingly important, I think, for breeds. Then, and this is what I'm just about to get into, then people are going to have to start thinking about, well, on what terms do people access reference information? Is it just completely free and everybody can tap into it? That'd be nice, but it's likely that there'll be some prices in some form. And people are going to have to think about, at the breed or an industry level, about, well, how do we fund the phenotypes? Do we just rely on stud breeders doing it because they like doing it? Or do we have to think about some conscious design decisions and funding decisions about our reference population? And then ultimately all that comes together in basically the governance of the breed or the industry population. Now, this might seem a bit bureaucratic and, I don't know, a bit formal or some other derogatory term, but in fact, every one of those decisions is affecting the fate of each of the breeds that you're involved in already. And how people make decisions about them individually and together are affecting everybody's ability to make genetic progress and everybody's ability to use genomics. And I think it's much better to be conscious about them than just sort of assume everything's fine. Just a couple of quick sort of slides to illustrate the idea about how things are changing with genomics. This is a kind of simple snapshot of how a breed society or a breeding group looks in the BLUP era. These are flocks, the blue circles are flocks with data. There are links between them. This is these blue lines. And most of them, I think all of them, in fact, are making some sales to the outside world. And because we've got genetic links and because we've got data, we can analyse all these flocks together and we can put them through SIL or sheep genetics. We can get breeding values and that's all good. Once we get to genomics, the thing that happens is that we effectively add a couple of things. First of all, we might add what I've called here specific reference, a specific reference flock or flocks. They might be the R&D flocks, but I've also suggested that at least a couple of these flocks here are doing some genotyping as well. And so these flocks, those two and that one, basically constitute what you might call the direct reference population. And everybody else can then benefit from that if they want to by genotyping. And we open up the possibility of an additional activity, which is this designated by this purple arrow, which is just genotyping animals using the reference data. So you don't do any measurement at all, you just genotype and you get useful breeding values. And that's, if you like, a second benefit that comes out, or third benefit, in fact, that comes out of genomics, is that you open up the possibility of being able to evaluate animals without doing recording on those animals themselves. And that's kind of really neat. So the three key features are: you can identify animals' merit earlier, you can potentially identify animals' merit for things that are really hard to measure, and thirdly, you can do it without any recording on the animals themselves. Now, so you'll notice I keep repeating myself. So at that point there with the purple arrows, no longer need to record to get a breeding value. But can't say this enough times, that's only true as long as the records are being taken on genotyped animals or their close relatives. And where this becomes interesting is that those records cost money, whether people think they paid for them or not. They've spent some time or money on getting them, and the risk is if too many people simply genotype and get nice breeding values from the reference population, effectively what they're doing is they're free riding on the people that are actually doing the recording. And if that happens too much, that will destroy the incentive to record, and there goes your brand, because once you stop recording, you've got absolutely nothing. You're in the woods with no clothes on, basically, and it's bloody cold. So that's a really nice thing, but it carries a really, really big risk with it. The opportunity, as I've said, you can evaluate animals basically at any stage of the chain, and potentially a lot more animals can be evaluated. You could evaluate all animals in the commercial population if the price was right. You can also use the genotype purchases to actually contribute to the cost of the reference, and I'll be talking about that in a minute. So you can set up a system where, by spreading the costs, you actually generate funds to invest in more reference phenotypes, and they are actually the source of your wealth. And I think they also lead to the idea that you can have a lot more partners in your breed brand. So basically, everybody who uses your genetics at any point in the chain, if they're genotyping, they are actually contributing to your phenotyping effort. They're getting some value, but they're also contributing value. So instead of having a fairly segmented, breeder, farmer, processor, consumer, etc., relatively unconnected chain, in principle, everybody who's using the genetics of a particular breed becomes partners in making the breed stronger. Now, I've thought a lot about this. I'm not trying to suggest I'm the only person, but I've thought a lot about this issue of the risk of free riders. If you have people genotyping and just taking value from the reference population, it could destroy the incentive to record. And I just want to spend a couple of minutes explaining how I'm thinking about this. And it basically comes down to charging for access to the reference population. And to explain the principle, I'll just quickly work through this. The nice thing about genomics is that it increases the accuracy of breeding values above that you get from existing breeding values. So this axis here is the existing accuracy. Up here is the genomic accuracy. And subject to the size of the population and the heritability of the trait, we can get a situation where if we've got a stud breeder, for instance, who's doing some recording, their existing accuracy would be shown by this green arrow and the line through the origin. If they genotype, they get a bit of extra accuracy because they're getting some benefit from the wider reference population. This person, the blue arrow, is someone who comes along and just genotypes. And again, depending on the size of the population, the heritability, and also how closely related to it they are, but they can get this accuracy here. So they're getting almost as much as the stud breeder. It's a pretty optimistic scenario, but nevertheless, the principle is they can tap into the reference and get this nice accuracy here. Now, these people, this green represents the cost of phenotyping, and the yellow is the genotyping these people do. All these people have to do is genotype to get up there. So I think somehow you've got to have some transfer of funds from these people to these people in order not to basically just drive all the incentive to record out of the system. The way I've thought about working this transfer out is to basically try to equalise everybody's return on investment. That's why it says equal ROI at the top, and I'll explain that now for a couple of minutes. So return on ROI just equals return on investment. The investment is the cost of phenotyping or genotyping or doing the two things together. And the return is the accuracy you get. Just going back here, so this person, or this sort of person here who's phenotyped and genotyped, they're getting that accuracy. This person here who's just genotyped, they're getting this accuracy there. And so that's the thing you get through this activity. You get accuracy. And to my way of thinking, a simple way of thinking about the return on investment is you just divide the accuracy by the investment. And so I've just done some work to set up a system where you can equalise those between the different players, and I'll explain that in the next couple of slides. you've probably worked out by now that I'm pretty much the world's greatest graphic artist. This is my attempt at explaining that concept. Here we have, this is a wishing well, or a water well, which is the reference population. And the reference population, in this case, it's got water in it, but the water's been contributed by different sorts of recording. So these green buckets are different recording effort. This is a small bucket, and you'll see in a moment that it's, whoever that is, they're contributing less information into the reference. This person or this type of person is kind of medium accuracy. This person is contributing larger chunks of accuracy. And so they put a resource into the well. And over here we have people who come along and take water out by simply genotyping. So these people over here are the people who do only genotyping. These people over here do phenotyping and genotyping. And they construct the reference, and these people draw on the reference. Now, all I want to do is to work out a way to basically make sure everybody's getting an equal return on investment. So to do that, all we need to know is the accuracy that each person is contributing, and that's what the R stands for. R stands for accuracy, which geneticists have a fairly interesting sort of early life spelling lessons. And dollars is the cost. So they're contributing accuracy. This person contributing lots, middle amount, little bit. These people get a certain amount of accuracy at a certain cost. And in this example, all I'm trying to do is work out how much do we charge these people for accessing the reference, that's this red arrow, and how do we distribute it back to the three different contributors. I've worked this example. This is actually a cattle example, so don't get too depressed by the dollar values here, but it shows we've got a reference that's got about 1,100 individual animals in it, and the people genotyping only, there's 12,500, so they're probably commercial producers. Given that, and I've got different levels of accuracy, 55%, 38%, 20% being contributed here at different costs. This is costing about $173 a head. This is costing $85 a head to collect that data. This is costing $50. And the equalisation system ends up being that given these numbers, we simply add basically a surcharge of $330 to the cost of genotyping for these people, and we distribute it. These people get $113 back per animal contributed. These get $43 and these get $28. And if you do the sums, everybody is getting equal accuracy per dollar invested in that example. So the concept is really very simple. You take account of how much accuracy people are contributing, how much they're getting, what costs people are paying, and then you equalise return on investment. So I've got, I think I've only got 2 slides left. That's just one way of thinking about it. I think it's possibly the greatest idea in the world, but it may not be. But it's a simple concept designed to try to make sure there is no free riding going on. That is what this is really about. And it's by redistributing some funds, it's helping the ongoing phenotyping effort. So just to return to the more general messages, I really want to stress people have got to think about not so much the traits that people are recording, all the time. It's what is going to be important in the future that you've got to invest in. And the sorts of things that I think are going to be really challenging are disease traits, welfare traits, environmental impacts, and detailed meat and consumer traits, things like marbling or zinc or iron content. And the challenges around those are, first of all, it's going to be kind of tricky managing the exposure of animals to disease when you're doing it quite deliberately to generate data. That certainly, I suspect, is going to pose some challenges in our countries to managing that, because just using field data means you've got to have enormous amounts of it because most diseases are rare. The other couple of questions, investing in traits that the market does not currently pay for. Methane, at least in Australia, is a good example. I'm sure you all aware we lag behind you a bit in terms of dealing with methane. Currently, there's no market price for methane. there's a pretty good bet there will be 5-10 years out. And so if the breed wants to be well positioned, it should be starting to collect methane data now, and that costs money. And so it's got to be factored into one of those buckets. The green buckets has got to include methane data, and you've got to know how much it costs. And so there's a bit of a punt there. It's like, well, is it going to be a long time in the future before we have to get paid for that, or not very far into the future at all? And then the other one is investing in traits that benefit different people down through the value chain. And certainly the case in our country, and I think it is fairly widely, breeders are pretty good at investing in traits where they get some sort of price signal back from the people who they sell rams to. But typically there's numerous traits where the price signals don't really come back from the consumer or whoever else it might be. And somehow or another, the breed or the industry needs to work out how to overcome that. Typically in Australia, and I suspect probably in New Zealand, a fair bit of that is achieved by using industry R&D funds. The challenge about that is you've got to keep doing it. You can't just do it for 2 years and have a nice project and say, whoopie-doo, we got some methane records, or some trait that benefits consumers. You've got to do it forever. So to finish off, sorry, I've just gone a bit over time, I think. Genomics changes and challenges everything, but in quite sort of positive and exciting ways. You absolutely have to think about what is important 5 or 10 years out, because you've got to be investing in data for those things starting right now. So the conversation about what you are breeding for becomes absolutely central. And then the second dimension is that you have to share the costs of that investment equitably and efficiently. I've come up with what I think is a workable model for doing that. There are probably other versions that will achieve some similar sort of end, but you've got to do those things that I've highlighted there on the screen. And anytime you think someone says, oh, we've solved the problem of data, it's bullshit. You've got to have lots and lots of the right data. So thank you very much for listening to me. I hope what I've said makes sense. I really appreciate the privilege of talking to you. Thank you. You're muted, Dan.
After all of this time, you think I would have figured that out, right? Thank you very much, Rob. That's awesome. And I mean, I guess it's almost self-explanatory why I think Sharon first did this presentation from Rob back in Australia at the end of last year, and why it sort of instantly struck a bell as to something that we really need to put a lot of effort and time and thinking into, and why we've brought it here to the Breeders Forum, so the breeders can start thinking about this and start helping us sort of figure out how we deal with this. I'm not sure if you heard the methane conversation last night, Rob, but very much the same challenge, right? So we've got a methane breeding value, we've got a way to test for methane, but it's expensive. It's expensive for the breeders who have to who take the punt to be the ones that are doing the phenotype collection at the start, and then we breed it out into genomic breeding values down the track. So there's probably 3 or 4 things with facial eczema, the disease trait in New Zealand, which is again expensive and difficult to collect, but we absolutely are starting to run into the challenge now of people who have genomic connections to the flocks which are collecting the phenotypes and want to be able to use those genomic connections as part of their marketing and sales. Residual feed intake is one that we're sort of starting to think about. The methane is obviously another one, and there was another one I had in my head as well. But I guess the reason for having you speak to us, Robert, and for the breeders now is to start thinking about how we do this equitably, how we share it across. You're right, at the moment, a chunk of it is around industry funding. But you're right, Rob, we can't just carry on doing these things. We can get them started, but we need a way to keep the data coming in year after year after year. So our tech team's thinking about it. We'd love to hear from the breeders and for breeders and commercial farmers and anyone else who's got some good ideas to fire them through to us so that we can chuck them into the pot. As it might be different for different traits. There might be different ways to deal with it, but I'm really interested in what farmers think about it and what's a fair way to do this off fecal egg counting. That was the other one that I was thinking of off the top of my head. So I really appreciate that, Rob, and I think we're back to you now, Sarah.
Do you want me to go through the questions that are on the chat group?
Yeah,
Yes,
I'll
you're
read
right.
them out to you, Rob.
I can see them on the screen, Sarah.
Oh, great.
Well,
So
sorry, I can see them on my screen.
Oh, excellent. So have you got the first one
Sarah,
there?
if you can, yeah,
From
still
Suzanne
read them
Rowe.
for the video.
Yeah.
Sarah.
Yeah, sorry. Well, if I lose it, tell me. Dan, remind me if I've got any time left, the point about you might deal with different traits differently. I've got a thought about that, but I'll just quickly work through the questions. Suzanne Rowe asks, what is the effective population size that you're assuming? I might have to think about that, and I'm happy to follow up with a sort of email, but I'm not quite sure exactly what the angle is, but you need a reasonable sized effective population size. The effective population size does affect the accuracy versus numbers relationship. Paradoxically, the more inbred the population, the smaller the number of records you need to get a particular level of accuracy from genomics, but you have other problems as a result of it. But for technical reasons, for instance, it's one of the reasons why Holsteins have got such high genomic accuracy in the world is because their effective population size is actually not that big. So I don't think I'm making any assumptions about the effective population size. You need to work out the accuracy and relationship for your own population. Suzanne also asked the question, does someone less related and gaining less accuracy pay less than someone who is more related and gaining more? Absolutely, yes. That's it's quite precisely what the approach I've developed is designed to do. That's why I've said it's an attempt to be equitable. Everybody gets the same return on investment. And so someone who is significantly less related will be paying more for access to the reference population. That does set up some interesting sort of operational challenges because up to a point, you don't necessarily know what sort of accuracy you're going to get until you get it. And so there's probably going to need to be some rules of thumb for people using a system like SIL. It's almost like operating a sort of rolling credit system. You pay something each year and next year you might get something back or some sort of rebate depending on what you got out of the reference next year. I haven't got an accounting spreadsheet or something like that to explain it, but it's a real challenge. If someone doesn't know what accuracy they're going to get, then they're not so inclined to pay lots of money for it. So you need to solve that, but I think it's doable. Sharon McIntyre asks, how do you envisage the fee would be collected and distributed? That's a very important question. It depends, I guess, on what sort of organisation you're talking about. There's no particular reason, I think, why a breed couldn't do it, but they've got to have some resources and some technical assistance to track the metrics, basically. Or it could be someone like SIL. As long as it's transparent and easily, it's got to be simple and clear and well explained. And I'm not underestimating the challenge of that, but if there is some, let's call it central organisation that is coordinating the analysis and the use of the reference data, it makes sense for them to be playing a role in a sense, collecting or charging the fees and redistributing them. I don't underestimate basically the organisational challenge or the communication challenge about that, but it's just got to be thought about. The next question from Annie O'Connell, commercial farmers capture a lot of the benefit from genomic predictions. How do they get to be represented in the management of the well? That's a really neat question. It sort of highlights the fact that they should be part of the governance of whatever the system is. Now, traditionally, breed societies, at least in Australia, are made up of stud breeders, and commercial farmers, they buy rams and that's the last you hear of them. I think what I tried to say about the changing nature of the organisation, you should be trying to include everybody who is using the genetics and potentially contributing to the reference everybody should be part of the governance. Now, in what proportion, that's a discussion, you know, how many votes do people get, how do they get represented and stuff, but commercial farmers do, or ideally they will be capturing a lot of the benefit, because that's a way to in fact increase the funding for your reference population. So making the pool of partners as big as possible is a really, really big strategic goal for any system like that, whether it's a breed or an organisation like SIL. That points to the fact that it's quite likely that some of the voice of commercial farmers might come from some sort of industry representatives as well. Now, someone just moved down to...
Sorry, Rob, we might just have to hold you there.
No, I'm running over time. But the last question is, for parasite resistance, the trait used normally is FEC, which is quite noisy. What is the added benefit of adding another measure? We have another measure called CALA, which is less noisy, but measures trait differently. It's kind of a simple technical thing. You work out how are the traits related, how do they predict the thing you're trying to breed for. You combine those two measures. If one's more expensive than the other, you might do less of that. It's technically fairly straightforward. It doesn't actually matter that the trait is normally, or that particular measure is noisy. You can take account of that. Can I just literally 15 seconds back to Dan's point?
You've got 10 seconds, Rob.
If you've got different traits that are differently affecting different players in the chain, then different players in the chain should contribute to costs. So the government might pay for methane, for example.
Yeah.
I'm sorry, I've gone too long.
No, that's right. It's been great to hear. Over to you, Sarah.
Thanks, guys. Thanks both Rob and Dan. It's a really interesting topic, and I'm sure, as we've seen, we can keep talking about it for quite some time. Now, refocusing back towards our national evaluation, we are going to hear from a series of experts on various parts of our analysis. First, we're going to hear from our in-house genetic evaluation guru, Sharon McIntyre, to give us an update on wool, data quality, textile genotyping, and upcoming base year changes to the analysis. This will be followed on by Cheryl-Ann Newman of Ag Research for a bit of a rundown on the research she's done on the relationship between the DPX sub-index and dose rate. And Tricia Johnson, also from Ag Research, will share with us an update on new FE research funding, followed on by an insight into meat eating quality and feed efficiency. Welcome, Sharon.
Okay, good evening. I'm Sharon McIntyre. I work with technical aspects of sheep improvement and would like to update you on some SIL changes and some future work we have planned. Periodically, we review a SIL module. The previous one was meat, which was implemented in 2018. We are close to implementing the revised wool module into NZGE. This topic has been covered at previous forum and also at last year's roadshow, so this is just a quick overview. The genetic parameters used to calculate BVs were reviewed by Ag Research based on all wool records in SIL. The heritability of fleece weight is unchanged. Fibre diameter has increased slightly, and there is less emphasis on live weight as a predicted trait for fleece weight. This probably reflects a more diverse breed composition of the New Zealand flock than when these values were first calculated. As part of the review, we also commissioned a review of wool pricing and wool quality traits by Abacus Buy. These are used to inform the economic values that we use in the wool indexes. Some traits had clear economic premiums, such as fibre diameter and colour, and other quality measures currently in place did not. One of the key price determinants was fibre diameter. The bottom axis along here is fibre diameter from 24 microns up to 40 microns, and on the vertical axis is the wool price in cents per kilogram. The vertical dots at each micron point is the variation in price across time. So you can see that the wool price has varied a lot across time, but there's a general trend that as you get to finer microns, the wool price increases. Currently, for Corridales, they're in this range here of 24 to 29 microns. We have a constant relationship reward for fibre diameter. So for every fibre diameter reduction, there's an increased reward of 66 cents. For our crossbred wools, Romney, Corriedales, Coopworth, etc., we just have a standard fixed price for lamb's wool, hogget wool and ewe wool, and that doesn't change. So it's based purely on weight. There is no reward for fibre diameter in our current crossbred wools. There are a number of breeders that are in this zone here of 30 to 35 microns that are trying to breed finer wool to increase the price returns for them, for their clients. Sometimes these breeders have been using the medium micron wool index to get a breeding value for fibre diameter and a reward. But if they use that index, it will overvalue the reward for micron. So this was a situation which was not as desirable as it could be. Abacus fitted the pricing trend to the data, and this showed a curved relationship with a steeper slope at the lower microns and a flatter to completely flat relationship at high microns. Using this non-linear approach to fibre diameter, similar to the approach we've taken with number of lambs born, we can have different rewards for decreasing fibre diameter at different parts of the curve, which is effectively for many different breeds where they fit along this curve. Because the fibre diameter changes with micron, all sheep breeds across the diameter ranges can use this one wool quality index. The other quality factor that has an effect on price is wool colour. Poorer colour wools are worth less as they restrict dye ranges and also result in duller colours. As wool colour is an expensive laboratory test, about $6 from memory, we have adopted the Sheep Genetics Australia colour scoring system for consistency. So in shed, when you're doing a shearing, you would score the fleeces for colour 1, 2, 3, hopefully not a 4 or 5, but it can occur. This can be done at a shearing when ideally there is some variation in colour. So if it's a midwinter shear and all the fleeces are white, you won't get any discrimination. There is a heritability component to wool colour which we're picking up with this system. For flocks recording fibre diameter and colour, the dual-purpose wool quality index will replace the mid-micron wool quality index. Because the fibre diameter reward changes with micron, all sheep across the micron diameter range can use the same wool quality index. So the DPW index, which is in the New Zealand maternal worth, it's the same equation, but you will see some small changes in the breeding values due to the change in the emphasis in live weight, and this will also result in some small changes in the index. The DPWQ index, wool quality index, will replace the mid-micron wool quality index, and it includes only fibre diameter and wool colour. If you include the dual-purpose wool quality index into your overall index, it does reduce some emphasis on other traits, which is the same for whenever you include extra traits in your overall index. It will change the emphasis slightly on the other traits.
Thanks for that, Sharon. Just while we're on the subject of wool, before we move on, we're going to run a poll. Now, this poll is around the inclusion of wool in the maternal worth index. Do you think wool should continue to be included in the New Zealand maternal worth? Yes, it should remain. No, take it out. Or also not sure. Few more seconds for the last few votes. Okay, so just over 50% agreeing that yes, it should remain in there. Thank you for that. Now back to you, Sharon, to continue.
So data quality is the next topic that I would like to talk about. Some of you may have in my data quality presentations at roadshows last year, and many of you may have experienced the disappointment and frustration when a highly rated animal goes from hero to zero. When investigating the causes for these, it's often due to data quality issues leading to an overestimate of merit in the first instance, which is then corrected by progeny performance. So, what is data quality? There are three key elements to it: the completeness of the data, so you've recorded all the relevant traits, the timeliness of the data, and also the quality of the data recorded. This can be things like the numbers recorded, mob coding, accuracy of measurement. In terms of timeliness, it was interesting to see how many 2019 born animals and all their data were added to the database in May. So any selection decisions prior to that time were obviously done without the benefit of any genetic merit estimates. So what do other countries do? The Irish have a data quality index where they score on those three aspects that I mentioned in the previous slide, and they have a target of 80% or better for their breeders on data quality. The Australians also have a focus on some quality assurance, and the ICAR, which is the International Committee for Animal Recording, they have an accreditation system for genetic evaluations, and one of the steps they require is that you have a data quality system in place. We do have data quality checks. When data is uploaded, there will be error messages if it's out of bounds or unexpectedly high or low, or the age of the animal is not appropriate to the record. But we don't have that oversight of the completeness and the timeliness that we could possibly have. So Improve is coming and is going to be implemented over the next year. So can we do something smarter? Can Improve give us some key metrics or some diagnostics or graphics that might give us some feedback on the quality of the recording that's being undertaken? So things like maybe a few week graphs might tell us something about the recording that's done. So in this instance, we're looking at weaning weight. So this is all the weaning weights we had on the females, and this is the later weight. So it might be a wee bit small, but this is live weight 6. So in stud A, we have no records on females post weaning weight. Now this is not uncommon in New Zealand. I quite regularly see this. For the males, we have weaning weights, and about half of the males had a live weight 6, and then a slightly smaller proportion had some muscle scanning measurements. This here is stud B. We have 100% of the weaning weights, and most of them, about 80% of the females, had a live weight 6, and similar for males, and the amount of eye muscle scanning. These are things that, for these females here, their later weights are going to be informed by their half-brothers and their sires. So instead of having good discrimination on these values here, they will be a poorer prediction than we would have if we had measured them. So over time, I think we should provide better feedback to breeders and assist breeders to improve their data quality, and think about introducing a New Zealand quality index. We live in an increasingly genomic world, yet for many flocks, improvement in accuracy of recording would give a substantial return through improved accuracy of predictions, meaning better decision making without spending money on genotypes. So basically you need the best foundation possible before taking that next step into the genomic world. We are interested in your thoughts on the introduction of a New Zealand Data Quality Index and welcome any feedback that you have. So this, improved data quality has benefits both for the breeder and for the purchasers of their stock, and for breeders that buy animals from them as outside sires, giving them the confidence to buy with insurances that the values behind them are as robust as could be. Okay, the next topic we have is the inclusion of texel genotypes into single step. The science team has been making really good progress on this, and it is likely to be implemented next season. There may be other breeds too that are working towards having genotypes, genomic information be included in their evaluation. It'll be a wee bit further away, but this next slide tells you the steps that the Texels are taking and that other breeds could potentially start taking to work towards this goal. So we require genotypes of 50K or high density on sires. So we want sires with good proven records, and we want them to have progeny with records of the traits that are of interest to you. Genomics offers the most value for sex-limited traits, traits that are measured later in life, or traits that are expensive or hard to measure. Traits that are recorded young in life, such as growth, become accurate quite quickly, whereas for traits like reproduction, animals are effectively sold on the mid-parent mean, as they do not have an own record or progeny records at the time of sale. The advantage of single step is getting more accurate estimates of merit for those sorts of traits than the standard mid-parent mean, leading to increased accuracy when making selection or culling decisions. So looking forward, what work have we got planned in the next year to 2 years? The next module that will be reviewed after WIL is implemented is growth. This is a trait that affects all breeders, so is very important. The growth module, we will be looking at, are there any new techniques that incorporate different ways of using the weights that we record? We will recalculate the genetic parameters to ensure it delivers the best possible results to all breeders. The index weighting index update is also due in 2022. It was last updated in 2017, so we have an aim of doing this every 5 years so we don't get huge jumps. We'd have smaller incremental changes that reflect the marketplace. So next year work will begin to analyse market signals and price trends to inform those new values. This work is usually undertaken by Abacus Bio, and they model those changes on a sheep production system. As part of that index update, we would also like to increase the base year from 1995 to somewhere in the 2000s. 1995 is 25 years ago, or about 6 to 7 sheep generations. I'm sure a few of us could name an ancestor that was 7 generations previous to us. So the influence they have is a lot less. In future, we would like to lift the base year each time we do an index update, so 5 yearly. So what does changing the base year actually mean in reality? Here is a genetic trend graph of New Zealand maternal worth, but it could just as easily have been New Zealand terminal worth or any sub-index. So this along the base here is the birth year, and the line indicates the average merit of all animals born in that birth year for that trait. 1995 is the zero intercept, and progress is gained relative to that 0 point. If we change the base year, say to 2005, the intercept changes to 0 at this point, which is now the green line. This means the genetic gain that was made in that period comes off here and is reflected over here, so about 400 cents in this example. When we do an index update, generally the price trends go up, so we see a jump in the index when we bring in the new values. So if we do a base year change at the same time as an index update, then we have an upward pressure from the increased values, and we have the downward from the change in the base year. So these will have a role in cancelling each other out to a greater or a lesser extent. So if I just indicate how this might work, is that green line, once the index is updated and the base year changed, that line will move. It will be somewhere different, I suppose. But how much they cancel each other out will depend on those index update, the economic weights. For some it may be above the line, for some it may be below, and it will be different for different indexes. But it does have, if we do it at the same time, it will negate some of that change. I know this is quite a complex topic to get your head around, but 2022 is 2 years away, so we have some time to talk this through and get people understanding how it would work. But for many of our new generation farmers, 1995 seems like forever ago. A base year that is in the 2000s, I think, is highly desirable.
Thanks for that update, Sharon. We've got a few questions for you now. The first, is coefficient of variation included in DPWQ?
No. So DPWQ only has colour and fibre diameter in it. You can record those traits and you can report those traits, but they are not in the index. We did not find clear price signals, so we were unable to put them into the index.
Okay, great. Given the lack of wool value at present and likely into the future, is there still a need to have wool as part of the standard New Zealand maternal worth, or is it time to make wool an optional sub-index, the same as meat, body condition score, FEC, etc.? You will have seen the poll that came through, but
yeah. So that is the question we get asked, and it is something that we're looking for a bit of information from breeders on, and that poll was just one aspect of that. So I haven't got a yes or no on that, but we are certainly seeing an increase in shedding flocks on the system at the same time, and an increase in flocks breeding finer. So there's a range of strategies being employed.
yeah. If you are not weighing females after weaning, but do weigh them as toos and subsequent matings, does this fill the gap?
No, it doesn't, because live weight mate is used in the prediction for adult size. So live weight 6, 8 and 10 are used for the prediction for post-weaning growth.
Okay. What proportion of maternal breeders do or don't record fleece weight?
That would be hard for me to answer off the top of my head. I'd be best to get a proper number and get back to that person on that one.
Yeah, sure, no problem. Now, you mentioned updating the relative economic values about every 5 years. Can you give us some feedback on why you wouldn't do that more often, despite the obvious workload?
Yeah, there's certainly a workload involved, because we look at what the trend has been for the past 3 years and what we think the future trends would be. It's quite a substantial piece of work. Some evaluations possibly do it sooner, but 5 years seems to be sort of a manageable number where we still keep up with trends without sort of disrupting things too much. And people get used to particular values, and every time we change those values, they have to get used to a new scale. So it's trying to find that sweet spot where it's up to date but not too frequent.
Yeah, absolutely. Thanks very much for that, Sharon. Oh, no, hang on. I will ask one more question that's just snuck through. With Improve, will we be able to customise the graphs to increase the readability, say having more flocks on one graph or more graphs on one page? Genetic trend graphs, that is.
Well, that's probably a David Campbell question, but my understanding is that the new report writer that will be built into Improve is quite powerful and allows quite a bit of scope.
Yeah, completely agree, Sharon.
Great, I think that's us there. Thanks for that, Sharon. Now I'll pass over to Cheryl Ann for a rundown on relationship between the DPX sub-index and dose rate. Welcome, Cheryl Ann.
Cheryl Ann, are you muted?
Can you hear me now?
Yep, we can hear you now.
Thank you. Technical issues. So I'd like to present a brief background to the SIL facial exome module to set the scene, and then cover some work we've done more recently.
Cheryl Ann, you're coming through quite quiet. Is your microphone down?
Yep.
And if you can spin up your video, that would be great.
More technical difficulties. Sorry, David, it's not giving me options to.
It's okay if it's not going to cooperate.
It's not showing me anywhere to spin my video up, which
Yeah.
is quite good. Start my video.
Here we go. Thank you.
Right, all good now?
Yep.
Thank you. Right, so sorry, starting again. I'd like to present a brief background to the cell facial lecture module to set the scene and then cover some work that we've done more recently. Okay, background. So in 2003, the facial eczema module was added into cell. It was based on Chris Morris's work in the 1990s and with a moderately high heritability for log GGT21 of 0.41. In 2015, the genetic parameters were re-estimated by Catherine McRae using an industry data set which included 20,000 animals from 111 flocks which had been tested through the RamGuard program. The heritability was re-estimated as 0.42, so very close to the original estimate. This data set was also used in conjunction with genotype data to develop genomic breeding values. There are limitations with the facial eczema module compared to other traits because few animals are measured due to test costs and protocol requirements. The facial eczema module returns GGT21 BVs, and these are used to calculate the dual-purpose facial eczema index. This graph plots the facial eczema index, the DPX values for size from linked flocks with the values color-coded by dose rate. The dose rates are shown here from 0.2 through to 0.65. And you can see the spread in the index values and also the different dose rates across the line. Flock and dose are confounded because generally a flock or progeny from a sire are only tested at one dose rate, and breeders often ask about fitting dose rate into the model. I have done some work fitting dose rate in the analysis, but there's not enough linkage to separate the effects of dose rate and flock. And so this graph's an example of what happens when we fit dose rate. So we've got the values, the original breeding values, sorry, this one's a breeding values, and if we fit dose rate, what happens to breeding values? It does adjust the BV so that animals responding at a lower dose rate have poorer values than those responding at a higher dose rate. But this occurs over the whole range of animals, the whole range of breeding values. So what happens is the animals at the higher dose rates don't appear as good, don't have as good a BVs when they don't respond. So the whole line shifts rather than just the top half shifting, which was probably what breeders are after. To be able to fit dose rate, we would need sires to have progeny tested at a range of different dose rates so we could take out the flock effects. I don't want to go back. I've also looked at adjusting the DPX value after the analysis. So we could, an arbitrary figure so that breeders dosing at higher dose rates would get promoted and higher index than those dosing at lower dose rates. This would require quite a bit of work to work out what would be a fair value to adjust the index post-analysis. But the interesting thing was this work gave us some interesting results. So if we go back to the DPX graph here, and we've moved the different dose rates apart. So I've just shifted the dose rates so we can see the spread of values at each dose rate. So the highest dose rate, 0.65, this is the values here, and we've just moved each line by a bit more so they can see the low dose rate values are here instead of having them all overlay on the same line. This showed that under the current analysis, the index does reflect dose rate, with animals tested at the higher dose rates, the blue and orange lines here, having higher index values, and animals that are tested at the low dose rates, the grey and browns here, having lower index values. There's another way to visualize the data, perhaps to show this just as clearly, is we fit dose rate along the axis here by the DPX value. Again, you can see the size at the high dose rate have the higher index values, with the size at the high dose rate having DPX values of greater than 1,000, whereas the size at the low dose rate is only one sire that had a DPX of over 1,000, so they have lower index values. And we can actually plot a line through this that shows what the average of the DPX at each of the indexes is, and it shows there's a difference in the values of 2,000 cents between the size at the low dose rate and those that are on the higher dose rate. It's progressive as we go through. There is a spread in the values at each dose rate. So there is quite a spread, as you would expect from any breeding values. And you can see that some animals have a higher index than what you might expect for their dose rate. We have had a look at some of these animals, and these animals here in particular that are higher than what you would expect for a dose rate of 0.45, the sires themselves were dosed at 0.45, but they had progeny that were actually dosed in a flock at 0.6. So these, and passed, so these animals are actually reflecting that the progeny were tested at a 0.6 dose rate. So this work's provided us with confidence that the analysis is doing a reasonably good job at identifying genetic gain for breeders that are testing at higher dose rates. That's the conclusion for my interesting work. Thank you.
Thanks very much, Sherilyn. Before we field questions on FE, I'm actually going to pass over to Tricia Johnson to give us an update on some of the new FE research funding that's just come through.
Sorry, Tricia. Yep. Sorry, Tricia, we'll just get you access. Yeah, Tricia, if you click the mouse now, you should be able to advance the slide.
Not at the moment. Here we go. Oh, yeah, it's a bit. Can you take me back?
Yep, no worries.
Yep, cool. Alrighty. So what I just wanted to really briefly cover under the topic of facial eczema, I guess the first graph here is why we're interested in facial eczema as breeders. Some of you will have seen this picture before. It comes from a paper from Margaret Demina back in 2009, where the graph on the left is areas where facial eczema has been an issue historically, very much restricted to kind of coastal areas in the North Island and that upper half of the North Island. Under climate change scenario of 3 degrees climate warming, the graph on the right kind of represents the areas that Demina predicted would be affected by facial eczema. And back in 2016, the areas that were affected were very similar to what we have there on the right. And so about that time, a national group was established, the Facial Eczema Working Group, and they have really been championing for education and extension around facial eczema since then, but also to try and drive for new funding to undertake research. So just prior to lockdown, one of my colleagues, Axel Heiser, went around ag research and kind of collated all of the knowledge that we have around areas where new facial eczema research could or should be undertaken. Genetics around resistance, diagnostics, understanding the pathology, the role that copper and zinc play in that pathology. Axel has a role in doing some work around a vaccine, and whether or not there are different diagnostic techniques that could be used to look at subclinical disease apart from just measuring GGT, which is non-specific. And then thinking about the fungus, whether there are additional things that we could learn about the life cycle and environment and ecology of the fungus. Because a lot of the work that was carried out, if you look back in the literature, there was, I wouldn't go as far as say hundreds, but well, probably through the 70s and 80s, there were hundreds of papers produced about this type of work, but we've come a long way in some of our science techniques and we haven't really revisited it to try and address things. So as a result of that meeting, and Dan Breyer is on the call, Dan and the team continued conversations with Axel, and Axel has been able to obtain kind of a first level of funding to be able to start looking at some of the work around the diagnostics and so the cell culture based assays. So what the idea behind that is that instead of having to actually artificially dose the animals with the sporidesmin toxin, that you would be able to take a blood sample or an ear tissue punch like you do for DNA at the moment and be able to have that bit of tissue or that bit of blood actually measured to determine whether or not the animal is tolerant or not to the sporidesmin. So that tissue or blood sample would actually be exposed as opposed to the animal. It is very preliminary research at this stage, and there are multiple phases before we would know whether it is going to work and be able to be an alternative. But to be able to have funding to start down that journey is just, it's absolutely amazing. One of the other things that Beef and Lamb, together with other industry groups, are recognising the merit in actually trying to package together a pan-industry research program that would look to something like potentially the Sustainable Futures Farming Fund, sorry, SFFF, to be able to support some of the research in this particular space. So it's really awesome to finally have some novel funding in this area and to really start the journey of being able to get some alternatives to ramguard into the future, but also be addressing that facial eczema issue if it is going to grow for us as a country.
Thanks very much for that, Tricia. Yeah, it's really great to see the first step down the right path for those alternate testings. Now we've just got one question come through for Cheryl Ann. Questioning, would this suggest people not dosing starting with negative DPXs? I assume that's referring to one of your graphs there.
I was looking at sires that have been tested.
Okay.
So it was a biased data set.
Yeah.
There would be, yeah, you've got to have links to get reasonable breeding values, so we wouldn't be looking at breeding values from sires that are not, flocks that are not testing.
Yeah, okay. If there are any more FE questions that pop through, we'll pass those along. But for now, I'll pass back to you, Tricia, to give us an insight into meat eating quality and feed efficiency.
Cool. Have to wait and see which one you loaded first. I'm conscious that we are running behind schedule a little bit, so I will try and make up a little bit of time in these presentations, but certainly if anybody wants to discuss them further. But David, I'm not seeing my presentation at the moment.
Yeah, sorry, I'm Trish, I'm just trying to find the additional slides after the ones we just had up. If it's okay, could we, Sarah, we might move through to the poll, and then
Sure.
do the breakouts, and while we're doing the breakouts, we can find those slides for Tricia.
Yeah, okay. So the poll, actually I'm going to throw to Dan to ask the question around the poll regarding the frequency of the New Zealand genetic evaluation runs.
Yeah. Hey, so this is a question that we've been sort of challenging ourselves with at BLG. So one of the things we do, and we pride ourselves on doing, is providing a genetic evaluation every week. But that brings attention for us. So it takes a lot of energy and effort to get that done, and we don't really leave ourselves enough time to necessarily do all the work we need to do to make sure that the run keeps coming effectively. So and efficiently, right? Some of you will be aware that at Christmas time we had a problem with the genetic evaluation right at the key time of the year when people were trying to extract information out of the cell system. So that was, I guess, that really reminded us that we need to think about how we do this. Quick kudos and thank you to Michael Lee and David, who worked through Christmas Day to get the NZGE stood back up for us. So my question for breeders is, if we were to not run the GE every week, what is the frequency that you need, and at what times of the year is it really important to us? So there's three answers here for you. Is it weekly in the peak season and then fortnightly off the season? Is it fortnightly, which is what they do in Australia, or is it monthly, which is what the dairy industry do in New Zealand? So I'm really interested in your thoughts on that. We want to know what you need so that we can make sure that we fold that into any decisions that we make. just about finished there now. Cool. So, and thanks very much for that feedback. That's great, right? So some people, the general consensus there, not very much for the dairy option of monthly, but certainly some fortnightly and mostly weekly in the peak season and then fortnightly off. Right, I'm going to pass back to you, Sarah, to drive us here. Thanks very much for your thoughts. I appreciate it.
Great, thanks, Dan. It sounds like we've managed to get your slides working now, Tricia, so I'm going to bring you back in, hopefully.
And I'll just assign control. Sorry about that, Tricia. We had a bit of a technical glitch here.
Sorry, and now I'm having a technical. Right.
Okay, we're just giving you access. So when you're ready, you should be able to control the presentation.
Alrighty.
Thanks, Tricia.
Cool. Alrighty, so start mode. There we go. So the first topic that I will be covering today is around feed efficiency. And I know that efficiency can be tagged to many words. Some can be around ewe efficiency, some can be around productivity efficiency. So the word feed efficiency is very specific in what it actually describes. And if people do have different views around what efficiency should be covering, B+LNZ Genetics would be open to hearing about those, but this is very specifically around feed efficiency. So the question around feed efficiency is whether or not similar animals eat the same amount of feed, and the answer is more than likely not. And so RFI is our rate of residual feed intake, and it is the actual amount of feed an animal is eating versus the predicted amount of feed it should be eating. And we predict based on the live weight of the animal and the live weight gain of the animal. And we kind of model out over the whole population of animals that we've measured what the normal amount of feed for a normal individual who is 50 kilos growing at 200 grams a day would need to eat, and then we see what they were actually eating. But as we all know, being able to measure this out in the field is nigh on impossible because we can't accurately estimate how much feed an individual is actually eating. So back in 2015, the Infome Feed Intake Facility was established. If you came to the original Breeders Forum, we were in a slightly different facility, but the same machines were there, and those that a few have been through subsequently to the new facility where the animals have a much better view of the Infome farm. But so we have 20 of these feeders that can measure 200 animals at a time, up to 200 animals. And so we kind of split them, 10 feeders on one side, 10 on the other, and have 100 animals having access to 10 feeders. So all of the animals are fitted with an electronic ID that is recognised by the feeders, and we can kind of go from there. So what we do with this facility is we can measure 160 to 200 9-month-old ewe lambs from industry progeny tests. And what we do is we ultrasound scan them at the start and the end. We're interested in the eye muscle area, but the key trait we're really getting from that information is fat depth C. During the time in the trial, they're measured and weighed twice weekly on a Monday and Thursday. And the reason that we need to take multiple measures is that we really want to accurately predict their growth rate during the trial. Anybody will know that on a given day, an animal can not be quite standing on the scales right, or have done something just before they've arrived. That means that their live weight can be out just slightly. And so if we were to base all our information on just a few live weights, we have a lot of noise and variation in that. We get them adjusted to the lucerne pellets that they eat while they're in the facility for 14 days. Most are good at adjusting, some are just a bit stubborn. And once they've kind of established and eating those lucerne pellets really well, we go ahead and measure feed intake for 42 days. That 42 days is as much about trying to get that live weight gain profile, because they actually have pretty stable intakes once they get established onto it, which is pretty cool. This is an example of the absolute extremes. These are just individual animals, but this is animal 1 and animal 2. This was in one of the last cohorts that we measured through the facility back in 2017. And they had very nearly identical live weights. They were growing at nearly identical growth rates. But little Gutso here on the top was eating 3.5 kilos of those pellets every day, whereas little Miss Efficient down here was only eating 2.5 kilos. So there was a full kilo difference in the amount of feed that those two individuals were eating for the same live weight and for the same growth rate. Those are examples of very extreme individuals, but it does show the amount of variation that can exist in this trait. So what we did between 2015 and 2018 was that we measured about 1,000 ewe lambs from the B+LNZ Genetics central progeny test, the flock 2638 that Suzanne Rowe referred to yesterday that's based down at Woodlands, and also the greenhouse gas selection line flocks that Suzanne referred to yesterday as well. If we kind of take the top 10% and the bottom 10%, there was about a 22% difference between those. Obviously higher, it was nearly 40% for those two extremes I just presented, but taking a group of top and bottom performers is about a 22% difference, which is consistent with the literature. So the heritability estimate from those 1,000 animals is 0.42 with a standard error of 0.09. So that puts it into being in that kind of moderate to highly heritable trait category. In terms of the correlations that we found, there is a different relationship with fatness, and it's one that we're still wanting to explore and understand more. To be able to lay down fatness, it actually is requires a lot of energy, but once subcutaneous fat is laid down, it's actually pretty inert and just sits there and doesn't require much energy. Whereas muscle that is laid down, it's relatively energetically easy to lay it down, but once it's laid down, it's always doing something and has a high energy requirement. One of the things, and I touched on it in a slide in a little while, is internal fat is a different depot of fat to subcutaneous fat, and it is actually metabolically active. And we are seeing, as I'll show in a slide, some differences between animals that lay down subcutaneous fat and internal fat, and we're just really curious to explore that relationship a bit further. Some of the really neat stuff that has come out of the trial is around eating behaviour traits. So some animals are just real piggies and get in there and just scoff their feed, whereas others are a lot more of a nibbler. So we have here two graphs. The one on the left is an example of a high intake rate animal. So if it was in the feeder for 1,000 seconds, it was eating about 600 grams of feed for that 1,000 seconds. Whereas this girl over here, she would rather just take her time. So if she was in there for 1,000 seconds, she was only really nibbling away and eating about 200 grams of feed for that particular amount of time. And it kind of, a very straight line fits across the data for each of those, that it's a very consistent trait for the individual animals, the rate at which they were feeding. The other really interesting one was the number of times that the animals would actually go into the feeder. Again, for individual animals, it was very consistent. These traits have come through with moderate to high heritabilities as well, which again just highlights that a whole lot of these traits around feeding behaviour are under genetic control. The really cool thing, and I said at the start, we have to do it in this type of facility because we need to predict the intake of the animal with a whole lot of accuracy, and we just can't do anything at pasture at the moment to estimate individual animal intakes. What we are working on at the moment is being able to use something like what we have here on the bottom left, is called an inertial measurement unit. It's really no different to what any of us have in our cell phones, that kind of your phone knows if it's pointing up or down or to the side. That type of information is captured from this device, and we fitted them to the little jaw of the animal up here. And so it was sitting underneath there, and you get these kind of profiles that describe when the animal is eating and kind of how, but it's all numbers and a lot of gobbledygook. And so we need to be able to try and convert that to actually describing if an animal is eating or not, and could we predict the rate at which it was eating. Whether or not an animal was eating or not, we can predict with really high accuracy, over 90%. The rate at which it's feeding is a little bit more problematic. The accuracy is only about 50%, but my cool result of the week, and I literally only got this data the other day, was that the guy that's doing the work for me, he said, I've done the modelling, I predict that this animal is a high rate feeder and that this animal is a low rate feeder. By pure miracle, they were actually very similar in terms of their live weights, and they were very similar in terms of the amount of feed that they were eating on a given day. But this animal was spending almost twice the amount of time in that feeder to get that same amount of feed. So that one there was one of my low rate feeders, and this one was a high rate feeder, and he was able to accurately predict that for me. So if we can then try and take it out into the paddock and have that kind of information, it's not going to be as perfect and as accurate as what we have in the facility, but if it can be used in a way where we might just need to collect more data to get information, but it's done out in the paddock, then that would be a really awesome step forward in being able to actually measure intake at pasture and be able to kind of re-estimate it. So the other comment that I just made earlier was around fat distribution. For the first 600 girls that we had as part of the trial, we did put them through the CT scanner at Infome with Innovision, and we were able to look at their fat distribution. So the top example is just the type of information that we were picking up, and this girl here on the left was 28% fat, whereas the girl on the right here was 45% body fat. But the other thing that we were able to pick up is this difference between this animal here on the left having very little subcutaneous fat as it runs just under the skin, but quite a lot of internal fat, whereas this animal here had quite a lot more subcutaneous fat just running through there and very little internal fat. And we're just working through the analysis of that data as well. But again, it seems, and it's actually even in higher heritability than some other traits, there's definitely genetic variation between individuals and where they're laying down that fat. So we're restarting. I've been using the facility for some other trial work over the last year or two, but we are about to recommence our relationship with B+LNZ Genetics to be putting through the low input progeny test ewe hoggets through the facility. They're due to arrive in about just over 10 days, and it's a 17 industry sires, and we'll be measuring just around that 170 mark, so 10 progeny per sire. So we look forward to generating new data and being able to present the results from that into the future. So that is feed efficiency, and conscious of time, I'm just moving straight on to acknowledgements. Quite a lot of funding from B+LNZ Genetics, Ag Research and the PGGRC for that. So David, do you have the next one ready to go? So the topic of this presentation is around meat quality. So over the last decade, we've really seen a change in the way we refer to the meat that we produce. We really are thinking about the consumer as being the end of the value chain and who is actually consuming the product that we produce on farm. And so we really have seen the terminology that we use when we're describing our meat that we produce really flip around. And so terminology like plate to pasture and fork to farm, as opposed to the reverse when it used to be in the opposite direction. So it really is placing that emphasis on the consumer traits and the consumer's acceptance of the product that we are producing. When we think about consumer traits and what customers are looking for when they buy our product, they are looking with their eyes and they are deciding what they perceive to be the optimum lean to fat ratio and what they see. They need it to be visually appealing. They need it to have a consistent eating experience. And traits that go into that eating experience from a meat science point of view are pH, tenderness, colour stability, and intramuscular fat. And when we think about this high quality, consistent product, there are a number of ways in which it can be implemented, with some of them being around pre-slaughter handling, which will affect things like pH, on-farm management, genetics, and post-slaughter processing. Post-slaughter processing can impact on things like tenderness and pH, but something like the trait of intramuscular fat is something that is very much driven by on-farm management and genetics, such as the fact that at the time the animal goes on the truck, intramuscular fat is fixed and can't be manipulated by anything that happens at the plant. So when we look and we start thinking about meat quality, we've gone through decades of selection for improving the lean meat yield of our carcasses. If we go back to the 1970s and beyond, we had our refrigerated or frozen shipping trade where fat was actually a desirable attribute for that refrigerated shipping that was required. But we've gone through a long and very successful process of trying to actually remove a lot of carcass subcutaneous fat. And so the question is, have we actually gone too far, and have we started to strip off too much fat from our animals? So intramuscular fat, many of you will be familiar with it, but it isn't something that we've often talked about in our lamb. You'll often hear the word intramuscular fat or marbling referred to in a beef context, so something like Wagyu that has a lot of intramuscular fat or marbling. So what we're looking at here is we have our subcutaneous fat, which is over this loin here. We have intermuscular fat, which is the fat between muscles that can be found throughout the carcass. And then we have our intramuscular fat, and that is the visible, IMF can be referred to as marbling, but it can be at levels that are significant but not detectable by the human eye. So why are we interested in intramuscular fat? Intramuscular fat is a key driver of meat palatability, and it's directly linked to flavour. A lot of the fat-soluble compounds are found within, the flavour notes are found within that fat, and also the fat composition can impact it in terms of the fatty acids that are present will impact on the flavour. It also impacts on tenderness and juiciness. And variation in intramuscular fat accounts for a significant amount of variation in the consumer acceptability of red meats. When we think about intramuscular fat, we know that it can be measured in a number of ways. And the question is, how can that actually be implemented in breeding programs? So the kind of gold standard for how intramuscular fat can be measured is that it is measured using wet chemistry, and it's an objective measure where you get an absolute number of the absolute amount of intramuscular fat that is in that piece of meat. You can use a subjective marbling score. Trained people can look at that piece of meat and they would probably score that one somewhere around maybe a 4, that it has a moderate to high amount of intramuscular fat in there, but not the highest level. The area where ag research and beef and lamb genetics have been spending money over the last number of years has been around the spectral imaging, and this is an objective way through which you can estimate intramuscular fat. So here on the left, we have a hyperspectral imaging camera that it goes through and does a scan of the meat, and it is predicting and gaining data on individual spectra in the near infrared wavelengths, that it then goes ahead and we use in further process data to be able to predict what the intramuscular fat is. To be able to do that, we do require some objective actual measurements for the training of it. Same goes here on the right. We have NIR, which is another alternative technology, again, gathering data on the spectral imaging, or spectral wavelength, sorry, of the meat that it is seeing, as opposed to here where we have a full scan of the meat. Here it is just measuring what it can see within here. So the question is, what is the level of intramuscular fat that we actually need to ensure meat eating quality, and where are we sitting at in New Zealand kind of currently? So when we look at overseas literature, the Australians have actually recommended that they would like to see 4 to 5% intramuscular fat in the meat that they are producing to ensure consumer acceptability, and that's been determined through taste panel analysis. But they do tend to slaughter their animals at a higher carcass weight than we do in New Zealand, and the animals do tend to be older. Something that is slightly more comparable for the New Zealand setting is work that was done in Scotland a few years ago, where they determined that 3% was the optimum or kind of really minimum required, is probably a better term, to ensure the eating quality of the product that the consumers were consuming. And recently, within New Zealand, just within the last few months, and it isn't published yet, so this is kind of a little bit pre-published information, but we have undertaken similar taste panel work in New Zealand, and very similar to the Scottish scenario, we have determined that 3% is kind of the target that we should really be aiming, because above that there was a very high acceptance of the product that was being consumed, and below that it was a little bit less. So where is New Zealand sitting in terms of its intramuscular fat profile? This is data that was collected through the beef and lamb genetics progeny tests back dating from 2014 through 2016. This is a little bit biased in that the way the progeny tests are conducted is that all animals are slaughtered on a given day, whether or not they are at commercial target carcass weights or not. And in some cases there are more male lambs represented, but in some ways that also represents the industry that females are retained within breeding programs. But what we can see from these graphs is that if we were setting that 3% as our target, we do have a lot of animals being produced at the moment that are below that 3% threshold. But that said, there are quite a few animals above that as well, and some are going up as high, as you can see there, 6 to nearly 7%. So there is a lot of variation in this trait, but it's something that we've never really looked at or thought about before. So over the last decade, there have been a number of studies that have started within New Zealand to try and understand the genetics around intramuscular fat. And across several studies now, we've determined that it's actually a highly heritable trait. When we do the wet chemistry measurements on it, which are really accurate and precise and kind of take out a whole lot of noise, we get very high estimates of the heritability of the trait, ranging from 0.5 to over 0.7. And so that's as high as you get for any traits, really. So it's pretty exciting to have that kind of result, because it tells us that there is a huge amount of variation from which we can select for into the future. The predictor traits that we have worked up around something like marbling score or the NIR or hyperspec predicted are slightly less heritable, probably more in the kind of 0.3 to 0.4 range. But that is because there is kind of more noise in the data, that we're using different machines in different years and different meat plants and different environments in which we're collecting the data. But the really critical thing, and this is again a kind of hot off the press result, is that we have been able to determine that the genetic correlation between predictor traits such as marbling score or the NIR or hyperspec predicted and that actual measured intramuscular fat is really high. It's above 0.9. So effectively we can hand on heart say that we are measuring intramuscular fat as the trait using those technologies, and it's doing a pretty good job of being able to determine in a genetic perspective which the best animals are and which the not so good animals are. So one of the things that does come through, and again it's part of the analysis that we have carried out, and it really comes as no great surprise, that there is a moderate positive correlation with carcass fatness. So for all of those years that we have been trying to remove subcutaneous fat off those carcasses, we will have been removing intramuscular fat as well. But the key thing is, it isn't a correlation of one, it's not the same trait. So the key here is that if we can measure both traits, we can actually start to make genetic selection pressure on both traits. So this is just a very rough and ready example of considering GR or fat depth as it's measured in the works against changes in intramuscular fat. And so if we have 0 weighting pressure on intramuscular fat and a 1 unit emphasis on removing our carcass fatness, we'll do a great job of removing carcass fatness, but at the same time we're going to be reducing our levels of intramuscular fat. And so what this graph just shows is that each one of these dots is where you're just placing a little bit more emphasis on intramuscular fat and what happens. So if we get to the point where we're kind of no longer changing intramuscular fat and it's staying kind of neutral, we are still making progress in removing carcass fat, just not as much as we would have if we'd been putting all our emphasis on removing that carcass subcutaneous fat. So this really just does go to highlight that we can make selection pressure in both. It just means that depending which way you're looking at it, if we place just a little bit of emphasis on intramuscular fat, you'll make a little bit of progress, and if you place a lot of emphasis on it, then you will be decreasing that rate at which you're taking the carcass fat off. But the key here is that instead of being in this position here, we can actually make progress in both traits if both traits are actually measured. So in terms of implementation in IMPROVE, as we're going to be calling it soon, I think now, is that there is a meat quality index available in IMPROVE already, and it's available to those that are genetically linked to the South Island Genomic Calibration resource that was originally funded a lot through the Farm IQ program. And the key traits that it measures within that are marbling score, tenderness, colour and pH. And there is discussion about these traits being added to other progeny tests. We are looking to implement the actual IMF predictors of NIR prediction and hyperspec prediction into IMPROVE, so that we can use that other information that's available on quite a few other progeny tests into IMPROVE, and to ultimately come up with a selection index that can utilise that information kind of to address the concerns of that previous slide, so that we can actually make simultaneous progress on both of those traits. And so I really guess the key take-home message from this is that intramuscular fat is an important trait if we think about consumer acceptability and consumer preferences, but it's a trait that we haven't historically paid a lot of attention to, and potentially we've been removing it through our really hard selection on removing carcass fat. That's not to say that we need to completely reverse everything that we've done, absolutely not. But what we do need to do is to just make sure that we have balanced breeding programs that are measuring both intramuscular fat along with the other meat quality traits together with those carcass and lean, so that we can actually get that balanced breeding program moving forward. Thank you.
The open mic session is an opportunity for breeders and commercial farmers and other involved industry parties to put forward your suggestions to Beef and Lamb Genetics as feedback. As I mentioned earlier, this may include things like emerging traits, parameters for specific traits, updates to the analysis, queries around indexes, or suggestions for research. An invite will pop up on screen asking you to join a breakout room. Please accept it. If the invite disappears, jiggle your mouse and it should pop up again. You can unmute yourself and turn on your video when you enter the breakout room. There will be a time limit and you will get a notification when time is nearly ending. Once time is up, you will automatically rejoin the main room again. Be careful not to click leave meeting in the bottom corner. This will end your Zoom meeting, not the breakout room. When you rejoin the main room, you will need to mute yourself again and turn off your video. Each group will have a moderator which will help kick off the discussion within your group and ask you each to provide feedback from your perspective within the industries. Your groups should be assigned now. Thanks everyone for joining the breakout sessions. I appreciate we're getting pretty close to the end of our time here, but I hope you all had a chance to share your thoughts. I know there'll be more to come, and we are very keen to hear more from any and all of you. So please feel free to email us directly. I will also touch base with each of these moderators afterwards to grab any more feedback we don't touch on now. But I'm going to just work through the list here of the moderators, just to ask each of you to share the top 3 that you've managed to write down over our quick breakout tonight. So first up, Richard Lee, if you'd like to share your top 3.
Am I unmuted? Yeah, okay.
Yep, we can hear you, Richard.
Sarah. Top 3, probably we spoke most about disease traits, particularly facial eczema. Secondly, in terms of new traits, methane, but there was a bit of a mixed opinion about whether about the cost effectiveness for individual participants about pursuing that, and then also meat quality. So those 3: FE and pneumonia / disease traits, methane, meat quality.
Great, thanks for that, Richard. Next up, we've got Daniel Wheeler.
We covered one and a little bit topics, but a bit of discussion around genomics and the risk reward costings and the practicalities of bringing that in. How do you reward the guys that are doing the recording and what the practicalities around that? We had a good mix of people from different parts of the industry. So from the commercial farmers' perspective, they were keen on getting accuracies, and that was the main thing they were concerned about.
Great, thanks, Dan. Robert.
Sorry, am I muted?
Can hear you. No, we can hear you.
Yeah, disease in general, so not just FE, but also other diseases, foot rot and pneumonia and things included. The low input traits in general, yeah, whether it's worms or tails, Burbrich, and yeah, most other topics were mentioned: wool quality, meat quality, feed efficiency, and methane. But one other point that I think also a good time to make sure it's heard is that feeling from breeders that breeders need to be listened to, not only, and response from them. There's advisory groups that seem to come and go, and not a lot of the sort of points raised at advisory groups are often carried out.
Great, thanks, Robert. Simon Buckley.
Yeah, just hoping you can all hear me.
Yep, we can hear you, Simon.
Good, very good. Yeah, general concern about the freeloaders. So that the breeders are doing the work, and there may be opportunities for others to capitalise on that via genomics. So that was a common thread. Meat quality, pretty broad topic, but you know, I think everyone's aware of some of the traits that are coming into focus there. The bureau structure, something again that's not directly related to traits and things, but yeah, key person risk, and I think all of us are pretty, well, no, I shouldn't say all of us, a lot of us are dependent on a key person in a bureau. If they run over by a bus tomorrow, a lot of us would feel like we'd be in trouble. So the bureau structure needs to be looked at. And lastly, the low input flock. Yeah, very impressed by all the work that's going on there, but a little bit of concern about the relevance of that to people farming in widely differing environments, and whether those same results, traits or measurements might be applicable to them, and how that could be widened out to include some more farms or operations. I think that's about it for us.
Great, thanks for that, Simon. Danny and Anna, I think you're actually in the same group in the end. So Danny?
Hi. Yes, so the topics that we discussed was around facial eczema and the need to find an alternative of finding tolerant animals. The other one that was discussed was the multipliers in genomics, and yeah, so that the free riders get accounted for, but also that we actually, if you have a multiplier flock and you are linked to the reference flock, that you actually get genomic breeding values that are comparable to what comes out of the NZG currently. And another thing that was, around New Zealand maternal worth and the wool index. If you stop measuring wool, will that affect your linkage for your maternal worth index? That was it.
Okay.
Thanks,
Sarah, I think we had a bit of a roaming issue on the last room. So I think it was Richard Shaw, Hamish Delatour. Would one of you be able to give an update?
Oh, well, if Richard's in Taupo with the lights off, I can do it, but it was Hamish Bibby seemed to be, it was only Hamish Bibby and I that were the breeders on that group. And really, we, FE genomics seems to be important, and still old chestnut of survival methodology of recording and the risks of being linked to a flock that's recording survival in a very different way, or in some sort of inconsistent way to perhaps what's acceptable or whatever, just because it has such a big effect, or can have such a big effect. Yeah, those were a couple of main things we were talking about.
Great, thanks for that, Hamish. Now, I'm just going to let you all know that the FE questions and things that we missed earlier will be asked after I conclude this meeting with thank yous and things. I'd really like to thank the moderators just now for being involved in the feedback sessions. I really appreciate you helping us to gather this valuable feedback. I know I'll have a few more conversations with you all after tonight's sessions to capture a bit more detail around some of those points we've just raised. To conclude this evening, I'd like to start off with a thank you to all our speakers and contributors. We really value your time and contribution to help us all further our understanding in your areas of expertise. We've had some wonderful insights and interesting discussion across a wide range of topics from this forum, which I hope you've all managed to find some value in. I'd personally like to share a big thank you to the BLG team, past and present. There's been an immense amount of work behind the scenes getting to this forum, and while again it wasn't the original format we'd planned, I hope this has given many people an opportunity to join us and expand their knowledge. And finally, I'd just like to say a big thank you to all of you for joining us. This is a wonderful industry to work in, and it's people like you tuning in from far and wide that we work so hard for in the hope of bettering this industry. So thank you for being here and showing your support. As I say, there will be an email link to both sessions of this virtual forum emailed out and posted on our website, as well as dedicated forum follow-up newsletter where key points will be reiterated and the feedback from this evening's breakout rooms will be shared. Now, feel free to stick around. I'm going to ask Cheryl Ann to jump back on and answer some of these questions around FE. Now, the first one came through asking around what about liver samples from the works? Hopefully, Cheryl, there you are.
Tricia can hop in if she's got any more information on FE than what I'm aware of. At the moment, we don't have a test to handle that using liver samples from the works.
Thanks.
And the risk, there would be a risk that it would be affected animals that were going to the works.
It often is, if they're too severely affected, they don't actually end up in the works as well. So it is potentially a bias sample, and it is just getting that tracking of animal information back So yeah, it hasn't been particularly high on the radar just because it has quite a few fish hooks with the information that we would actually get.
Yeah, great. Sherilyn, is there any ongoing support for connectedness for FE breeders, given that it is the only way for a crossbreeding value to work well?
At the moment, there's not any. The progeny test that was the DOFE isn't proceeding as of last year, so there is no active support. I guess breeders would have to band together and seek funding from a funding body or put a case to BLG or something like that. Sorry, nothing from my side.
I think following on from that, perhaps, is there anything being progressed on improved genomic prediction of FE? Are the phenotypes and genotypes in this area sufficient or needing a boost?
The more phenotypes and genotypes you have, the more accurate the genomic prediction can be, but there are sufficient to get a genomic prediction, and improving the genomic prediction is an ongoing process within the single step evaluation. So it's not a static evaluation, it's including all new genotypes and phenotypes that are coming along. So the accuracy will be increasing as long as people are phenotyping enough animals.
But I guess the key point on that one is that there are about between 1,100 and 1,400 animals that are going through the RamGuard program every year, but not all of those are actually being genotyped. I couldn't tell you, and Sherilyn would be able to figure it out at some stage, but not all of them are being genotyped. So there is a loss of value for the overall system through them not all being genotyped, given the expense of actually getting those phenotypes.
Great, thanks for that, Tricia. The final one, I think, is there any research done to look for novel biomarkers in animals for FE?
Yep, so that is definitely, there have been studies over the last few years. There was a study out of Massey a couple of years ago. Zoe Matthews conducted a study. It was a dairy cow based one. She really didn't come up with anything better than GGT or GDH, which are the two key ones that we use at the moment, but there definitely are some industry initiatives to maybe look at that. And that is another one of those ones where the science technology that we have is forever improving, in terms of we have a whole lot of new ways of looking at some of those potential biomarkers. So yes, there definitely is intent to kind of try and look for more. Whether it's successful.
Yep. The deer industry are doing a little bit of work on use of biomarkers, so it may be that the sheep industry can piggyback on the deer for a change.
Great, thanks for that. Now, I think we had a couple of questions actually from yesterday. I think they were for Suzanne, if she's still on. Hopefully, she might still be here with us.
Yes, she is. Yep.
Oh, great. Hi, Suzanne. Just a question around what do commercial farmers think of methane? Are they aware of this activity and value of it yet? And I guess that's referring to the recording of the methane in the packed chambers.
I guess the short answer is I don't know. The people that I've spoken to obviously are biased because they're aware of it, or I wouldn't be talking to them. So yeah, I guess that would involve a wider survey. I think pretty much everyone that I've spoken to, regardless of be they public, commercial, know that we all have to do something. You know, it's here, it has to be approached. Most people are actually relieved that there's something that they can do. But in terms of the value proposition, again, we don't have a value proposition because we don't have a cost. So until we have a cost, we can't develop a value proposition. So it's pretty hard to explain to people what the value is to them, other than we know that the industry has been given a target, and it's been given a date and a target. So, you know, we have to lower enteric emissions within the time frame that's been set. So, it's there and it's coming. The train's coming down the track, so we can't hide forever. But as I say, until we really have an economic value, we can't really provide a value proposition.
Yeah, that's fair. Thanks, Suzanne. I think there was one more question for Cheryl Ann. I was mentioning it would be good to get more detail about your analysis of the DPX. For example, what the GGT results were for animals that end with a low DPX or high at varying dose rates. Have you got any comment on that?
I would have to go back to my evaluation and pull up some figures for that. It's probably something we could perhaps do a summary of and include a summary of the whole stuff that we'd included tonight in the BLG newsletters or something.
Yeah, that'd be great. Okay, I think that just about wraps up our questions. If anyone has any more questions, feel free to fire them through the chat. I'll just wait on for a minute or two to see if any more pop up. Here's a good question. This might be a Dan question potentially, but should BLG be paying for genotype on all FE tested rams? Shirley, and while you're there, you might be able to give your 2 cents on that one.
No easy answer to that. Depends on your perspective. If there should be enough value in it that breeders would want to genotype the animals they're already paying for to phenotype. So there's no easy answer.
Yeah.
Can I hide behind Cheryl Ann? So I mean, that's a really good question, and I think that's Russell hiding, being Kate tonight. It's a good question. I guess we're always going to have the challenge of how we share the funds that we get largely from commercial farmers in New Zealand, and how we share that across the breeding industry. So that's going to be a tension across all sorts of things. Meat quality is going to be the next one that we have to try and address. How do we put money towards meat quality, which we know customers are going to be looking for soon, or do we say it's just a matter of priorities? But yeah, good question and tough question.
While I've got you, Dan, what will be happening with Sheep Advisory?
Yep, so the Sheep Advisory Group, I spoke with the Sheep Advisory Group back just before the lockdown, perhaps, or around about then. And so we'll continue to use the Sheep Advisory to give us advice and to be a bit of a voice for breeders coming through, helping us make sure that we're making good decisions and give us some advice and make sure we're staying on track.
Yeah, great. There's a question come through from Anna Martin. Is there any plan to look at methane emissions and feed efficiencies in the same animals? I can even answer that one. So the low input progeny test is actually going to do just that. We're planning to feed RFI test these animals in the coming weeks, as Tricia mentioned, and we will also look to test the methane emissions of those later in the year. Another FE question, should breeders interested in improving FE connectedness and accuracy of DPX start getting together to put a case together for funding, or are we exhausted on this?
Dan, do you want to cover hook?
Sorry, I might need to.
I guess the point I would make on that is that with the support of Beef and Lamb New Zealand, there are definitely, we're as close now to actually trying to get the new industry funding for facial eczema as a topic on itself outside of necessarily Beef and Lamb New Zealand, certainly with Beef and Lamb New Zealand support, but with Dairy NZ's and the deer industry and other groups buying into that. But one of the key things that will be required for that to fly is certainly the industry support and buy-in. In-kind contributions definitely always count, but cash contributions from industry groups do also weigh in quite large on things like the SFFF funding, and those kind of initiatives really are to be industry led with support from science versus the other way around. So I think there is momentum at the moment, and so it's just really supporting Dan and his team coming together with Axel and myself and the ag research team for actually getting on with something.
Yeah, and so I would, now that I've caught up with what the question is, I agree, Tricia. I guess we will need a coalition of the willing to make it happen, and we will need in kind, and we're going to need cash. And so with the Beef and Lamb New Zealand team, sort of trying to understand and think about ways that we could get people who are really interested in this to actually, so individual farmers maybe who are interested, or trusts or whatever, to be a part of putting some money into it, because that really does speak to the funders at SFFF. It's easy for people to rock up to them and say the industry should do this and you should put some money in with it, but when they see individuals putting their own cash up, they know that they really mean it. So watch the space, hopefully.
Great, thanks guys. And I think the final question Ross had for you, Tricia, are you able to comment on the value of BLG funding genotyping of FE tested animals?
Dan has kind of already covered it, and that there is a limited pool of funding in terms of who can jump highest and loudest, I guess, but I mean it is around the economics of it as well, and Dan and the team have an exceptionally hard job of prioritising what is a limited pool of funding. I guess one of the tricks about facial eczema is that there are some breeds that are well represented within that 1100 to 1400 that I was referring to, and so the genomics for them is kind of an easier sell. There are still some breeds that have relatively low numbers of animals being phenotyped or measured using Ramguard, and so there is always going to be just that little bit of a challenge, but I'm certainly, I can't override Dan on any allocations of where the funding is going. So
yeah, no, thanks very much, team. Right, just to wrap up, video links will be sent out tomorrow. That will include, as I mentioned, Tricia's meat quality session, which she unfortunately didn't get time to do earlier. I will be in touch with all of the moderators from the breakout sessions this evening, and you're always welcome to email us directly for any further feedback. We'd love to hear it. So thank you all very much for joining. I hope you've enjoyed, and enjoy the rest of your evening.